Good afternoon, everyone. Welcome to EUC1363. We're here to talk about Mirage. This is the desktop management software that VMware recently acquired from a company called Win7. My name is Jay Tallman. I'm a product manager with VMware in the desktop group. And joining me on stage today will be Issy Benchal, who's one of the co-founders of Win7. And so we're here to take you through a deep dive of that product, that technology, and how it can change the way you think about desktop management for both virtual and physical desktops. So let's start by asking the question, why is desktop management so hard? Windows has been around for the better part of 20 years, and there are plenty of tools out to help you manage desktops in the enterprise. But there's still some problems that just continue to vex desktops and continue to vex IT that make it more difficult than it should be. First of all, application compatibility. I put this down to the way that Windows enables shared code so that applications can take advantage of common libraries on the operating system. This is a great convenience for developers because you don't have to deliver the entire stack for an application. You can take advantage of things like .NET frameworks, Java runtimes, browsers, and other things that are expected to be on the operating system. But that also introduces a trade-off where you have to worry about compatibility. What if two applications need two different versions of .NET or two different versions of Java? What if one app doesn't work with another app? This is a problem that seems to be unique to Windows. I don't have this problem on my Mac, and I don't have this problem on my mobile devices. So app compatibility is one problem. Another issue is that the desktop use case has fundamentally changed since Windows and many of the desktop management tools were introduced, and that's mobility. Users are no longer tied to a physical PC that is chained to a desktop with a LAN cable always connected to it. They're roaming with their mobile devices, they're going offline, they're working from home, they're working at Starbucks, they're in airports, hotels, and they expect to have access to that same desktop no matter where they go. That changes the picture, and you're not always going to be able to connect to a user's desktop in order to manage it. So you need something that allows the user to roam, to be disconnected, and to pull in the management changes as they're needed. We still deal with hardware failures. I hope you got to see the great demo in the keynote yesterday morning where Vittorio slipped and fell off stage. Sorry, no such shenanigans today. I'm not going to, whoa. The fact of life is when people are walking around with their computing devices, they're going to get lost, they're going to get broken, there's going to be hardware failures to deal with, and you need a good way to recover from that. Similarly, laptops can be lost or stolen, left in taxi cabs, left in airports. There are hundreds of laptops left in every airport at the TSA screen every day. And those laptops, or those users who leave their laptops behind, need an easy way to get back up and running with their old environment as quickly as possible. And then finally, even if everything goes well, there's always going to be a constant treadmill of patches and updates that you need to apply to desktops to address security vulnerabilities and just get the latest and greatest versions of all the apps and operating systems that those users need to do their jobs. So desktop management is still hard. And VMware, let me say that for every $3 that you spend acquiring a user's machine, organizations will typically spend $3 in operational expenses managing and keeping those machines healthy and up to date. So this is according to a study by IDC. So what's the answer here? Do we shift everything to virtual desktops and let users compute out of the data center? Well, that's a complicated question. VDI is a tremendous tool, and it has a number of benefits for both IT and the end user, and a few negatives. So you have to weigh the pros and cons carefully as you're considering whether virtual desktops are the right solution for your use case. For IT, it's great. You get central patch and image management. You have all your desktops in one place. You have good image backups, very low risk of data leak because the content, the applications and data all stay inside your data center. And users can connect from anywhere. So IT can deliver low-cost thin clients instead of more expensive fat clients. The downsides for IT are some of the high upfront costs. If you're going to take all that desktop compute and move it into the data center, you need very good performing blades, and you need high performance storage to be able to handle the IOPS for an operating system that was developed and designed for local use on a physical spinning hard disk. It's also a challenging environment to troubleshoot sometimes due to the complexity of centralized virtual desktops. In order to get the most bang for the buck, you want to have non-persistent desktops where the user persona comes onto that session dynamically. That just fundamentally changes the way that Windows works, and to the uninitiated, it can be a pretty steep learning curve. Now, for the end users, VDI is great because it allows them to work from anywhere on any device. And their applications are going to perform the same no matter what device they're connecting from and what the nature of their connection is. You keep the application close to the data, and it's always going to perform well. When I'm running Outlook in a VDI session and I download a 15 meg PowerPoint presentation for somebody, that presentation stays in the data center. I don't have to download it over my choppy hotel Wi-Fi connection. On the other hand, there's some trade-offs here as well. I can't work offline and still call it a true centralized or server-hosted virtual desktop. And to whatever extent I have latency in the network between my client and that central desktop, there's going to be latency in the user interaction. Now, we saw a demo of AppShift in the keynote yesterday that can begin to address that sort of thing, but whenever you have that network connection between a user action and the resulting behavior on the desktop, that's going to be noticed by the end user, and it's going to make it challenging for some specific use cases. Also, in many cases, the user is going to be connecting to their virtual desktop from another physical Windows desktop. And this leads, for non-technical end users, to what I call VDI whiplash. They get confused about which copy of Windows they're really working with. Which C drive is my document really on? And switching back and forth between a physical desktop and a virtual desktop, while for virtualization professionals like yourself might be easy to understand, a typical non-technical end user might find this a bit challenging. So the bottom line is, it's a complex area. VDI is not a panacea. It's not going to be the one solution that fits all use cases. It's going to be an important part of the mix of desktops, but we don't believe that it's going to be 100% of your user population across all use cases. Particularly anytime you have machines that have special hardware requirements, anything that's hooked up to machinery or equipment on a manufacturing floor, anything that absolutely has to keep working when the network is offline, like a retail point of sale or any other mission-critical application. So Mirage is a new offering from VMware. As I mentioned, it was an acquisition of a company called Win7. This product is shipping today, and it changes the way that we think about desktop management and allows it to apply horizontally across all desktop types. At a very high level, the way you should think about it is that each user desktop is going to be synchronized with a server. And that server will maintain a replica or a copy of all of the files and folders on that user's hard drive that are needed to boot Windows, run their applications, and keep all of their data in sync. The difference is that once that desktop has been centralized, the Mirage server will treat the central copy, the server copy, as the primary copy of that user's Windows environment, and their desktop becomes a disposable execution container. And you can replace that with any other hardware type. You can go from one laptop to another laptop, change hardware, go from physical to virtual, and Mirage will take care of migrating that whole desktop image across to the different execution containers. It also keeps everything in sync, so the user can always roll back to a recent backup of their apps and data, and it takes care of the layering so that IT can now bring the same manageability benefits of VDI to physical and other types of Windows desktops. And it's important to remember that users are going to run that on their local hardware. They can go offline. It's not going to change anything about the way that they use their machine. So it's central management, but local execution. When you manage centrally but execute locally, it can change the way that you do many things around desktop management. OS migration becomes a different matter because the central copy of that Windows image is in the data center. I can upgrade that central copy from Windows XP to Windows 7, and then the clients will inherit that upgrade and be able to migrate to Windows 7 very cleanly. Hardware refresh becomes easier. I can move their image from one hardware machine to another, and only the driver libraries will be replaced. All of the OS and apps and user data and settings will be maintained as I go from an IBM laptop to an HP laptop, for example. Disaster recovery, as we saw, I can recover a broken endpoint onto a new one while maintaining the entire personality of that machine. In addition to the centralization, Mirage applies layering technology so that we can replace the operating system or applications inside that image and across entire collections of desktop. So we have a single image management tool that can very quickly re-image thousands of machines, get them upgraded, get them to new versions of applications, but merge that in with the user installed applications and data that was already there. It changes the way you do help desk support. If a user has a problem with their physical laptop today and you need to get into that laptop in order to fix it, that can be challenging when the user is in a hotel room on the other side of the country. With Mirage, you have that user's image in your data center already. You could temporarily assign it to a virtual machine and do the troubleshooting there instead. Or if you know that the user's machine was working okay 4 hours ago or yesterday, you can simply revert them back to a snapshot from that time and get them back up and running. And then finally, this is a backup solution as well. All of the user's data is going to be continuously synchronized into the central copy in the server. And if they need to restore something, that can be initiated both by IT and by the end user. So it's a comprehensive disaster recovery, image management, and backup solution for Windows desktops that horizontally applies to all different hardware types. And we think it's a game changer because it can give you a single tool to manage virtual desktops and physical desktops all in the same system. So I'm going to bring up Izzy, who is the co-founder of Wanova, to talk more in depth about the technology behind Mirage. Izzy?
Thank you. Thanks, Jay. Is it on?
You turned on?
Can you hear me now? Okay, great. Thanks for being here. Great to be part of VMware. So I'll take you a tour into a little bit into the technology and how what Jay said actually works. So it all starts with installing a Mirage client at the endpoint. It can be a virtual or physical machine. As long as it's a flavor of Windows, we don't really care. And the first thing that the Mirage client does, it basically analyzes the content of the image and then it centralizes the relevant contents into the data center, into an object which is a virtual image representation of that desktop. It resides in the data center and is used by IT for all management purposes. So IT takes care, looks at those primary copies of the images, uses them for management. However, we keep a cache copy of that image on the endpoint, so it allows users to continue to work and execute their workloads locally with native performance, offline capabilities, etc. From a system perspective, we view those endpoints as execution containers only, meaning that at any point in time, as Jay said, you can dispose of it, you can get a new piece of hardware or maybe a virtual machine, and we can stream that image into its new container for continued execution. And we'll explain how that works. But generally speaking, from IT perspective, we manage those logical copies that happen to be executing one time or another on different execution containers. That's the general concept. Now, this is centralization. It's not a one-time event because we need to keep it constantly synchronized. So periodically, we take a snapshot, a point-in-time snapshot of the system, use VSS, and upload it in an efficient way to the data center. So we always have the latest copy of the endpoint image in the data center. Furthermore, we keep not just the latest copy, but we'll keep up to 24 snapshots back in time so that if the latest one happens to be corrupted, we can actually restore a snapshot from the past, from nearly past, from week or days, and we show it. Actually, we'll have a little demo that demonstrates that more specifically. So that's from the endpoint side of things. At the data center, we have IT and provide IT the image composition and management tools to effectively have what we call single image management. So the IT person have a reference machine, could be a VM. He loads, installs a base image. He can install whatever applications he wants to deliver on top of that base core image. And then with a push of a button using a simple wizard, he can apply that image onto a large collection of endpoints. You can you can have several base images for different collections, etc. But the general idea is that we try to make that image as generic as possible. And I'll explain how we do that again shortly. But the idea is single image management that can be applied onto a large number of endpoints. Now, once again, this is not a one-time operation. It's not like an imaging or a ghosting and one-time thing. It's a continuous operation. So an IT can make some changes to the service pack or do some more significant changes, and at any point in time, you can reapply the image into the endpoints periodically, however it wants to. And again, it's, when the image is installed, it's sent out and it replaces the old image, and then in its entirety. So there is no installation of packages and stuff like that. Now notice the coloring scheme here. It has a meaning. It means that even though we support image-based management, we don't necessarily require to lock down the endpoints, and they can keep their own personal applications side by side the base image. So that allows many of our customers are knowledge workers, power users. They need to have some of their own personal applications that are not managed by IT, and they can be kept side by side. So even though after we do the initial imaging, subsequently we'll always merge those with the user-installed applications so they can have both types of applications side by side. Although we can provide for those IT people who are more strict with their policies also forcing them to clean up anything that's there if so desired. So both options are available. That's kind of the general scheme of things. If we were to implement that in a naive way, we would require tons of bandwidth for that to be able to synchronize all those changes upwards and downwards for image updates. But since we designed Mirage to operate over the WAN, that's actually the key use case for us. We've developed a very sophisticated network optimization layer that essentially minimizes the use of bandwidth and accelerates the completion times of the major operations through bi-directional synchronization and streaming technology that I'll dig a little bit deeper in the next slide. But that's, in general, the general idea about the system: centralized images, strong synchronization, local execution. The last thing at a high level that I want to mention is that, as I mentioned earlier, this is a little bit sometimes confusing, but Mirage client executes within the operating system that it manages. The implication of that is that we don't need an underlying hypervisor to run on the client side in order for Mirage to operate. However, if one such hypervisor exists, whether it's type 1 or type 2, we can happily work with it because we're agnostic to the underlying hardware, but we don't need one. And that provides several advantages because, as you may know, with type 1 hypervisor, you may run into hardware compatibility issues quite often. You could run into issues of forklift implementation and stuff like that, and it has its own issues. Type 2 hypervisor, on the other hand, are sometimes useful in a bring your own device situation, and we embrace those, especially if you have Fusion or Workstation as a type 2 hypervisor, where frankly, any hypervisor would do. But in some cases, it creates an overhead on the performance. It creates the issue of unmanaged host OS. And if IT wants to manage the host OS, it runs into the issue of having to manage two OSs. So in many cases, customers have told us, no, we just want to manage the base image, and that's the advantage that we offer in our architecture. So we have, as I mentioned, two kind of categories of technologies. One is the delivery, and the other one is the layering. And I'll get one level deeper in each of them now. On the delivery side, we have a set of technologies that we've developed to make sure, again, that we optimize those delivery of images. One of them, first and foremost, is a highly advanced log-level deduplication over the network. So, for example, you have 1,000 people in the organization, and we create in the data center a global cache of blocks and signatures. So if one user uploads data, the server will store the data locally in its cache and create an index for it or a signature so that if any other user sends, before sending the data, sends the signatures first, if there is a match, the data will be recovered locally without having to send the data over the network. So in an enterprise where there's a lot of redundancy between users' workloads, you can imagine that creates huge reduction in the overall upload traffic. Typically, we can see up to 90% traffic reduction. In other ways, we see sometimes on average maybe 5-6 megabyte per hour upload, even though the actual change set is way, way bigger, maybe 10 times bigger. So that's on the dedupe, and we also apply network deduplication on the downside. So if I have my own desktop, my endpoint, it does create its own smaller cache that it is used in order to deduplicate downloads onto the endpoint. And in many cases, it proves to be also efficient. In addition to the network deduplication, we have storage deduplication, which is, in our view, was essential because it would be very wasteful for us to centralize all those images in the data center and not do anything with them. There's a lot of redundancy, especially on the operating system and system files, but also in user installed applications. So we created a single instance store that effectively makes sure that there's only one copy of each file, regardless of the number of files of users that share that file. And again, this provides, as you can imagine, tremendous savings. We also have block-based, storage-based deduplication across snapshots for large files like PST files, et cetera, that again provide dramatic savings for that. So overall, there is a storage overhead, but it's relatively contained, and it doesn't have to be tier 1 storage like in VDI implementations because there is no latency sensitivity. The whole system is asynchronous, and therefore we don't need the high performance in order to access the storage. Another technique that we have, which is, I think, quite unique, is really what we mentioned, desktop streaming over WAN. What that means is that we analyze the content of the image, and we know to send only what we call the minimal set of files that are needed for the system to boot up to a login. Typically, it's less than 10% of the entire image. And when we push that and load it, the system boots up, starts running, and the rest of the image is being streamed in the background. So you may have heard of application streaming. That's analogous to this, except we do it for the entire system with everything, including the operating system, et cetera. So that really cuts dramatically on the time it takes for a user to go back into a working state after, basically from nothing. And even if it doesn't have deduplication because there's no there, it can still be there up and running in minutes. And again, where there's application streaming over WAN, we've seen some products that do desktop streaming over the LAN, high-speed gigabit Ethernet. We're not aware of any other product that can do desktop streaming over the WAN in its entirety. Another technique, so I mentioned that we do deduplication in both directions, but if you have something like XP to Win7 Migration, a use case that we support, then there's not much dedupe that you can gain from the Win7 to the XP. You can, maybe 20, 30%, but there's a lot of new stuff. And in order to overcome this, what we provide is what we call a branch reflector, which is the ability to designate in the branch endpoints and mark them as reflectors, which means that the image can be downloaded only once to them, and then the other neighbors or branch peers would actually pick the image locally from that branch reflector. So that's, again, cuts dramatically on the bandwidth that is needed in order to deliver things even to low bandwidth branch offices. Sorry. And last but not least, we take great measures to make sure that we don't affect the user experience. It has been always our kind of very important principle for all of the design. That's where we started from, make user experience well. And in particular, because we're asynchronous, we can afford not to contend with resources when the user is busy working with the system. So we basically sense keyboard, mouse activity, network activity, and based on that, we throttle down our activity to make sure that everything we do can be deferred until there's more available resources for us. Okay, so that covers the delivery framework, and now let's talk a little bit about layering technology, the complementary technology that makes all this work. As I mentioned earlier, there is, first and foremost, there is a border or a barrier between user-installed applications and managed applications, and they live side by side. However, unlike other technologies there, what we do here is we don't use some of the isolation technologies that you may be aware of, say, application virtualization. Those actually turn applications into bubbles, and there is some pros and cons to that approach. What we do is we actually take the changes that are made to the red layer, the managed layer, and we actually merge them with the blue layer to create one monolithic image. Once everything is streamed and in place, as a matter of fact, you could take out the one out of path, and it would continue to work. There's no redirection online, and Win32 API, interception, and runtime, all these things are not done. It's all done in the offline. At the same time, because of our integrated recovery, we always have the latest snapshot just before the merge occurred, and we can always revert if needed. But that's Now, you might ask, and I anticipate that question, so I'll answer it right now. What happens if there's conflicts, right, between the blue layer and the red layer? How do you handle that? So what we do is, first, we provide tools, analysis tools that we run. When you want to do an image update, there's a dry run tool that does a what-if analysis of what would be the impact if I did that change on the endpoints. Now, luckily, we have the endpoints already in the data center, so we don't have to touch the physical endpoints. We actually do the analysis on the images and create a report that generates any conflicts that might occur if I were to do that. So as an IT person, I have the choice of deciding to upgrade some of my stuff or maybe exclude some of the clients, et cetera. I have full visibility. That's number one. Number two, we have some default policies, right? And the default policy says that if you don't do anything, you don't have to worry too much, but then what will happen is the red will win. So base image wins policy. So I want to make sure that whatever is my managed applications in IT, they'll be enforced no matter what. And that allows us to constantly enforce the base image over and over and make sure that that works. So that's, on a nutshell, there's more into it, of course, but kind of at a high level, the idea behind the merge. We have another interesting layering piece, which is the hardware abstraction. So I mentioned how do we abstract or divide between the applications, but we also want to provide hardware agnostic solution that doesn't require a VM, remember. So in order to do that, we decouple the hardware dependencies in a separate layer. We call it driver library. And that allows us to reduce the number of images that we manage on one hand, and then being able to deploy those to a heterogeneous set of endpoints. And we do that by essentially assembling the relevant driver library to the target hardware together with the base image. And the reason we know what driver library to send is because when the client registers, all the hardware profile is part of his image in the data center, and it helps us actually to do the match what to send out. The last thing I want to say about this is that one of the things we always wanted to do is obviously centralized management, meaning that we don't want to require people to go in remote sites and do something. We require to have some technical people at the endpoint. So in order to do that, all of the operations we do are we call in zero touch, meaning that we send an image, and that image can be replaced in place with the existing image, with the old image. All the user has to do is reboot, and the image is replaced. So there's no need for Pixie boot or USB for booting a new image. It all is done in place. That means that as an IT, be centrally in one place, and then make sure that all those operations occur in zero touch. There is one case where we do need to have some external help, and this is when we have a bare metal case where there's no disk or a blank disk or no operating system on it, and then somewhat that needs to be bootstrapped, in which case we have a WinP-based bootstrap mechanism that can be used over a Pixie to just start the initial step, and from then on, the Mirage client connects the server and brings down the rest of it. But otherwise, all the operations in a steady state are zero touch. So let's go quickly through kind of a flow that takes all those pieces together and show what really happens. So let's say I have an image that I want to manage and apply. So I have a reference machine. We call that object reference CVD, but it runs on a reference machine. I install my image, I update it, I maintain it periodically. And whenever I decided I want to apply that thing, I basically issue a capture operation. It anonymizes the image, makes it applicable for a large collection of endpoints. And from then on, when the time is ready, I can apply that image onto, again, the endpoints. Obviously, some of the endpoints may not be connected at the time they do the apply, so they'll get it whenever they connect back. Connect to their server and then download them. But otherwise, those images are being streamed efficiently onto the endpoints. Then they're being in place replaced. All the image is being thrown out. The new image is being put in. The blue layer is kept intact and merged. And when that happens, a new kind of version of that instance is being uploaded as a new snapshot. And I basically completed a cycle of an update in this way. All this happens automatically. So there's one push of a button and the rest of it is being taken care of as part of the flow. So kind of to make the high points, remember, zero touch. I don't have to install any application package or anything. It all comes with the image, and I don't have to boot the system or from external media. Personalized applications are preserved. Highly WAN optimized, we mentioned that. I could stick a branch afflictor there and have just send it only once, but otherwise it's deduplicated. Minimal user downtime. So everything that we do is in the background. The users are not aware that this is happening up until the time that they are requested to reboot the system and upgrade to the new image. But otherwise it's completely unnoticed, and we'll see that also in the demo. And there's another interesting piece, which is the safety net that we have. We always can revert back to our latest snapshot, and again, very quickly, in case that update was for some reason not the right one. And people make mistakes, and that is, sometimes very useful. Imagine you apply an update to 10,000, and we have a customer that did that, 10,000 users, and it's a wrong update, and some of the key application is not working. How do you go back? How do you roll back to this? Because this is dramatic productivity hit. So with this, you can restore back, and again, very quickly go back in business. One other thing I want to mention about the system is, I think that's more relating to what you saw maybe yesterday with Vittorio's demo, is that we have part of the concept of the centralization and the hardware agnostic means that our vision really is that to make it possible for the endpoints to be continuously available, even though we don't want to compromise user experience. What I mean by that is that since we have hardware agnostic solution, one of the things we can do is if the system is working under steady state, but now the Dell machine laptop is not available for whatever reason, whether I don't have it with me because I travel or because it just got lost or stolen, I can instantly assign that object into a VM. For us, VM is just another type of hardware. We adjust the driver layer, we assign it into a VM, we stream the image in minutes. Now, all of a sudden, my image is available through any standard remoting protocol, which is outside of Mirage. You can do whatever you want to access it, but we provide you exactly the same image that you had on your logical image that you had on your physical, except there's some changes underneath, but logically, from the end user perspective, it's the same image. Then again, once I do have a new piece of hardware, maybe a different one, like an HP, I can, again, reassign that CVD from my repository, or that object, what we call CVD, back into the physical machine and continue my operation. So it's kind of continuous universal access, but with the ability to do physical. And as we go more into the roadmap, and Jay will talk a little bit more, we're also talking about how to do this in a multi-device fashion in a synchronous way. But today, we can transition from one to the other fairly quickly. One more thing about the system. So besides all the techniques that we have, we also made it possible, or was important for us, as an enterprise solution to make it scalable. For doing this, we designed the system with clustering, and which both for high availability as well as for scale up. So you can add servers in a cluster that are stateless, so you can access from the client any server. If one server is down, you need to add more capacity, you can do that. It's also relatively high density. Unlike, say, VDI, you can sustain with a quad-core blade up to 2,000 endpoints easily. Well, the reason is we don't run really Windows workloads there, so that explains the high density. But you can stack 10 of those for 20,000 seats in a pod that has been kind of officially approved and working. But it is scalable. You can add also storage nodes, etc. So the system is ready for large-scale deployment. With that, I'll turn it to Jay.
Thank you. All right, so hopefully that gives you a better idea of the technology behind Mirage, being able to centralize Windows endpoints, managing them from within Windows itself, and having a hardware agnostic way to move those images around onto different execution containers. So let's look now at a few real-world examples of how this can change your typical IT workflows. System recovery. So something goes horribly wrong with my laptop, my applications won't run, I call IT. What's the typical way for IT to solve that without Mirage? Well, you can completely re-image Windows, rejoin it back to the domain and get everything installed, and basically re-provision a new machine to that user, and then get the user's personal data restored from backup, and then the user has to go and install anything missing and get settled in again to make it his or her own machine once more. With Mirage, it's different. You have continuous snapshots of the user's workspace available to you. So the first thing you ask the question, or first question you ask the user is, was it working an hour ago or was it working yesterday? If so, you can simply revert them back to a snapshot, reassign the image to a new machine. The client's going to reboot and get right back up to their desktop, their messy desktop with all their icons and their bookmarks exactly the way it was, regardless of the hardware in place. What about Windows 7 migration? This is an important use case and something that customers are using Mirage for today. Without Mirage, you might want to prepare and ship a loaner to the user and have the IT take ownership of their XP laptop in order to get everything backed up, re-image it to Windows 7, rejoin the domain, install the software and the apps, restore the user data, do the user state migration tool and get everything back to the user, and then once again the user has to get settled in and repersonalize that new operating system. Very disruptive to the end user. With Mirage, you simply install the client on the XP laptop, and then you assign a Windows 7 base image to that machine. It's going to merge the Windows 7 operating system and files into that disk. The user state migration tool is actually embedded into the Mirage product and can help migrate the user's personal settings. The client's going to download all of those bits optimally from the server. They'll be prompted to reboot, and after the reboot, they'll come up into a Windows 7 image that has all of their apps and data, but now it's Win 7 instead of Windows XP. Everything happens in place, so there's no need for server infrastructure. There's no need for the user to ship their hardware to IT. For the end user, it's literally a reboot, and now they're in Win 7. As far as pushing that image out, as Izzy mentioned, we have a branch reflector technology. So you would start by creating a Windows 7 reference machine, capture the image out of that, and then when you want to send that to, let's say, 100 users in a branch location, you don't have to send that image across the WAN 100 times. You can send it just once to a branch reflector, and then all of the other clients on that location will download the base image bits from the branch reflector instead of getting them across the WAN from the server. So again, highly optimized, very efficient, and there's a built-in safety net. We'll have the continuous snapshots, and we'll be able to revert back to the Windows XP image if anything does happen to go wrong with the Windows 7 migration. We'll take questions at the end. Thanks. System repair. What's your typical support life like? You call Tier 1, they try to troubleshoot things on that desktop, maybe remote into the user's PC and troubleshoot issues there. And if it can't be resolved that way, then you're back to shipping out a new machine and trying to get that machine in-house where you can work on it. With Mirage, most of the time you can resolve issues simply by reverting back to an earlier snapshot. If that doesn't fix the problem, then you can temporarily assign the user's CVD to a virtual machine and bring it to your IT workbench, resolve the issue there, and then reassign the fixed image back to the user's device. So again, very fast and efficient. ADAC is a vehicle insurance and services company in Germany. To give you an example of the power of Mirage, they used Mirage for a complete desktop migration. This was a hardware migration to new laptops for 2,400 desktops. And they did this with, I think it was just 1 or 2 guys, and completed the whole project in 3 weeks. So that'll give you some idea of how much leverage you get when clients download their image from a central location and then do the update in place. And as is typical, they started with Mirage as a migration solution, thinking that it was a migration tool and then they would be done with it. But once they saw the full capabilities and how it could actually serve as their backup solution as well, they decided to keep it on with perpetual licenses. So let's take a look through the end user interface now. And I'll bring Izzy back up to talk through video. Turn it. Yeah.
Okay, great. Okay, so I'll walk you through a little bit more realistic demo that you saw yesterday, but real. And what you see here is an endpoint that is basically standard personalized endpoint. It has a bunch of user-installed applications, not corporate applications, more like things that I installed, JD2Go, FileZilla, etc. It has some my own documents, pictures, and users state that they typically keep with me, and it's still an unmanaged machine. What we'll see now is how do we basically, with Mirage, make it a managed machine. So we go into the Mirage Management Console. You'll see the dashboard, which treats the IT and gives you some key system indicators of the health and how much of the data is protected, how much of the image is being managed, etc. I go through my base layers, which is a set of layers that I have, and I collect a layer that I want to apply to that new endpoint that you just saw before. However, before doing this, by the way, you see there's an Office that is going to be installed as part of that process. It wasn't there. It's going to be installed there or be part of the new image. Before installing and applying the image, I want to make sure that there is no conflicts, as I mentioned before, that could be problematic. So I basically run the dry run report. As I mentioned before, it's a what-if analysis. It takes that image and compares all the endpoints that will be the target. In this case, only one for this demo purposes. And it generates that report. And when you see the report, it comes up as a page that shows the conflicts. Not surprisingly, in this case, as we saw, it's going to be just showing the Microsoft Office elements that are being installed. There's not going to be any conflicts in this particular case. But that's the general conflict report that exists. So I'm OK with that. I don't see any red flags here. I'm ready to continue. And then I continue with my wizard, and really, literally, with one push of a button, I am going to actually apply that base layer. I can apply it to a collection of endpoints again. Once I do that, then is there some validation? I want to show, for example, there's no 32-bit architecture that's going to get a 64-bit OS by any chance, and things like that. But once this is done, and the validation passes well, the process starts of the delivery. Remember, there's layering, there's delivery, and then there's a replacement. So we go back to the end user, and it keeps a small icon, tray icon that says that your system is being updated. But other than that, the user can continue to work basically as before, seamlessly. It's all happening in the background. You might see those are the Vittorious pictures, actually. But these are the user-installed applications that I had before. They're continuing to operate normally. I typically don't see any degradation in my user experience because of the throttling that I mentioned before. And then I can also click, if I really want to, I can click and see what's the progress. Well, we're fast-forwarding a little bit. It takes more time than you just saw here, but we'll see the statistics. I'll know how long it took exactly. At some point, I get a pop-up for reboot. By the way, I can control, as an IT, if I want to have that pop-up or force it or decide on the schedule. And this is where the atomic image replacement occurs. It takes usually more than that. It takes about 30 or 30 seconds. But then the system boots up, and I have essentially applied a new base image. So even though everything looks pretty much the same because my persona has been kept intact, all the image that I had in the data center has been applied. In this case, it was a relatively small image, but you see here's Microsoft. So all Microsoft applications are there. I can use them. I never had to install them. They're all there, pre-installed and ready to go. Because I do have now this layer of the image applied there. And once again, everything on the blue layer is still out there. There's no difference whether it's document, whether it's applications, etc. They've been merged into that image. Now let's look at the statistics. So we'll always have monitoring and statistics of each of the operations that we do. In particular, we can look at a transaction log for that operation that we just did. And we can go and see, okay, what was the network traffic associated with that? How long did it take, etc. And looking at that, we just inspect it, and we see that there's been about a 40% reduction compared to the original workload. So it's about 500 megabytes. Office was not heavily deduplicated, but it was still pretty much a nice saving. And it took 12 minutes. I forgot to post there, but it took 12 minutes to do this operation. And this is real-time numbers. So within 12 minutes, the process finished over the WAN. So we're actually switching now into a new use case whereby we're actually going to see a user is working. He's generating some content. using Word, but there is a problem. The problem is one of the applications has been corrupted. Okay? I'm sure that happened to you sometimes, one time in the past. In this particular case, we actually, the application that's corrupted is Excel. We try to run Excel, you click it, and it's not working. What do? Well, I call IT and I say, well, IT, you have to help me, something's not working. So with Mirage in place, what you really can do is you don't need to have a smart guy to be the guy who resolves and try to understand what's wrong, because he just looks and says, can you pause for a second on the snapshots? Yeah. And he can basically say, okay, so here's the last of snapshots. We just created this demo a few days ago, but here are the snapshots that are available. What was the system look like yesterday at 4:56 p.m.? He says, I think it was okay. So, okay, so I'll just revert to the snapshot. I don't need to know anything about why the registry is back corrupted, etc. I'll just take your snapshot back in time. And there's a little checkbox there that says system restore only, which means that I don't want to overwrite files that I created. Remember, I generated a Word document. I don't want that to be gone. So we do just, using the layering technology, we just take the 5 layers and keep the user data intact. And we have full control of those layers. So what happens is, once again, there's a little notification that the system is being restored as opposed to being updated, you saw code previously. And now what happens is, once again, we're actually fast forwarding it, but it is actually pretty fast. You'll see the statistics later. And at some point, again, the system, the user is asked to restart the system, and when he restarts the system, this time around, we're actually reverting back to the previous snapshot that was on the system. Using the same technique of in-place replacement, we take that image, and after reboot, the system has been fixed. Why? Because I'm back to the snapshot that was working early. So, and so I can try and see that, hey, my documents are still there. Because remember, we just did system restore only. We didn't want to touch our documents. Otherwise, they would be reverted as well to the previous section, but they didn't do, because here's my document that I just generated. It's still there. It hasn't been changed. However, the big thing really, of course, is that Excel is working. It's going to be the next click. So this is still my user installed applications. Nothing happened. But of course, when I'm going to use Excel, of course it will work, because it worked at that version. So there's no reason for it not to work. And the system is restored, again, with very minimal IT involvement and really short time. So going back to the management console and looking at the statistics again, what you'll see here is that there is dramatic savings. Why? Because only the very small things that fix the registry, etc., needed to be transferred because of heavy deduplication between the snapshots. So only 1 megabyte actually was transferred, and it finished in 2 minutes. The reason is because it was all deduplicated except for the elements that were corrupted. So that concludes the demo. I'll hand it back to you, Jay.
All right. Thanks, Tom. All right, so let's wrap this up. Where are we headed with Mirage? And the elephant in the room might be, why did VMware, a virtualization company that likes to talk about the post-PC era, go and buy a company that does physical desktop Windows management, right? And the reason is, we recognize that virtual desktops are great, but they're not going to be a panacea. They're not going to be the answer for all users. We see Mirage as fitting into all types of desktops, whether they're floating or persistent virtual desktops, whether they're physical laptops or ultrabooks, or point-of-sale machines, equipment on the machine floor, or BYOD machines. Just as Mirage can manage a physical desktop or a virtual machine running on the server, it could also manage a virtual machine that's running on a client, whether that's running atop a Type 1 or a Type 2 hypervisor, because it manages Windows from within Windows. We have this horizontal desktop solution where you can have a single tool for image management, app delivery, and repair across all these different desktops in the enterprise landscape. So we believe that that's important, and that you, as the desktop IT admin, are looking for a single set of tools that you can use to manage all your user desktops without regard for the actual form factor that users end up with. So today you might be managing your desktops one way for VDI. If you're using View, you would use Composer to have a master virtual machine, and that becomes the image management tool of choice for View. And then for physical desktops, maybe you have Golden Images, maybe you're still using Ghost, maybe you're using other forms of app delivery for those physical machines. Mirage has the potential to bring all of this into a single image management, backup, and DR framework where you can declare one single golden image for all Windows desktops in the enterprise, and then have that image be applied for central execution with VDI, in which case users would stream in or connect over the network and use a remoting protocol to get to that desktop. This is really the best solution for high security environments, for healthcare where you've got doctors roaming around to dozens of different rooms a day and you need instant access to your desktop from many different devices throughout the day. You could also use that same image to blast out onto physical machines, and that's the better use case for road warriors, for people who walk around with their laptops, or another term that I liked recently that I heard, or hallway warriors. If your day involves just going from meeting to meeting to meeting and you're walking around with your laptop all day long, you really want to have your workspace there locally with you and not rely on a network connection. And then there's a BYOD use case here as well. Just as I can run that image in a server-hosted virtual machine, I could run it at a client-hosted virtual machine. It works with Fusion on a Mac and VMware Workstation on a Windows machine. So you could manage that VM as the corporate image and leave the rest of the operating system alone if that device happens to belong to someone who's not in your organization. So I hope you're as excited as we are about Mirage. We think it's a game changer. If you'd like to see more demo, get your hands on, there's a booth downstairs in the VMware area on the Expo Hall. Thank you very much for your time, and we've got a few minutes for questions if anybody wants to come up to a mic and ask a question. Yes.
Does Mirage, is full disk encryption supported in Mirage?
Yes, full disk encryption is supported because Mirage acts as a file system filter, and so it will operate with the Mirage server just before it gets written to disk and encrypted. So on each user's client machine, they're encrypted with separate keys and then deduplicated still in the back end.
Yeah. So are the popular encryption products supported? Like McAfee?
Yeah, McAfee,
we
like,
qualified, yeah, most of the major disk encryption solutions, Guardian Age, McAfee, Checkpoint, all of those are qualified, yeah.
Question in the back?
Two questions. On the branch reflector that you showed in the example, how much, is it a dedicated device? Is it something that can be existing on an existing user's machine? What's necessary for that device?
Yeah, so the branch reflector can be any user device, and any machine that's in the system can be nominated as a branch reflector.
Okay.
If that's, you probably don't want to use a laptop for that. It's something that's going to be going into standby. If it's a reliable desktop, you can use that. If you want to dedicate a machine to it, then that works as well.
And then also for the road warrior type of scenario, I'm an IT director for local government, and so I have police officers that do not have a desk, they're strictly wireless the entire day on shift. So in terms of WAN connectivity, is that something that can be delivered over 4G LTE type of network? And then when that network is not available, whether we've lost tower or they're on a plane or whatever, does that bother the Mirage application in terms of losing that connection to get updates?
Yeah, so there's a reason that the company was called WANova. The first part was WAN, and ISI was heavily involved in a WAN optimization company before this. So yes, it works. It continues to work when the network is not available. It opportunistically downloads the bits from the server as it needs them, and only when all the bits are collected will it actually do the client-side merge.
It is actually designed for disconnected operation intermittently, so anytime you disrupt it, it continues from where it left. And
okay.
Yep.
Yeah.
Maybe, sorry, last question. Is there a direction down the road for a mobile user that might have a multitude of devices or endpoints? So instead of a dedicated patrol officer that has a machine in the vehicle, but then when they get back to, maybe they want to go to a shared terminal at the station, or they have a BYOD tablet or something of that nature, will this evolve into more than just an endpoint, I guess, to end user design?
Yeah.
Well, it's possible today to merge or to reassign a user's image to a virtual machine and then allow them to road in.
That's physically moving it from device to device, but if I can concurrently use three devices.
Yeah, multiple device sync is something that we've got on our roadmap, but it's not in the product today.
It's not today, but it's in the roadmap, and hope that we'll get it soon.
Thank you, guys.
Simple question on license. Now you have two images. What does that mean about the license? For example, Microsoft Windows license.
So you don't have two images. You're not running the image centrally. There's still only one copy of Windows that's running, so you only have one Microsoft license to contend
No,
with.
I thought the image in the Mirage server is
No,
live.
the Mirage server is a server, Windows 2008 R2, and it hosts the images and stores them in an offline version. So you don't have to populate them actively on a machine unless you want to do troubleshooting or reassign, in which case you do need to have for that VM the proper license, volume license or whatever. But normally you don't have to pay twice for the licenses because it's only the endpoint that you pay for.
Yeah, the Mirage image is just a collection of files that are needed to boot Windows. It's not a VM. It's not running Windows in the data center. It's a backup.
The reference machine is another one that you need to have a license for, but that's one, right, across, yeah.
Okay, question in the back?
Yeah, if you can't, say you have a boot sector is gone, what?
If the boot sector is
Yeah,
gone?
you can't boot into Windows.
If you can't boot the system, you need to, there's no other way around, you have to use external means to do that, and we have for that a boot USB that is actually well prepared ahead of time with WinPE, or you can do it through a Pixie that can allow you to bootstrap. So we have some roadmap to use some vPro technology from Intel to do some of it over the WAN, but it's not there yet.
So you can do Pixie boot over the WAN?
Okay.
That was a Pixie boot is available over WAN?
Say it again?
Pixie boot is available over WAN?
No, so
Okay.
for Pixie boot, you have to do it locally. If you want to do complete boot over WAN for a non-bootable image, you would have to use something like vPro boot over WAN. Yeah.
Okay, I think we've got time for one more question, and then we'll take the rest outside the room.
Okay. When reverting the system image from when we're using the snapshot to restore, let's say if we install new applications like after the snapshot was taken,
Yeah.
when we're doing that restoration, so let's say in the user case we had used Excel.
Yeah.
Excel was broken. We install more applications, user applications, and we use the snapshot to restore. When we do that restore, would it keep the new application that was installed? Would it restore? Would it
Yeah, the
remove
user
it?
installed applications will be maintained. You can choose to restore the base image only, which means only the part of the Windows container that you want to manage will be merged in with the rest of that user's desktop. Now, if the part that you have ownership of happens to conflict with something else that's on the desktop, your piece will win, but user installed applications and data will not be disturbed unless you choose to do that. That's an option in the system. You can enforce the base layer, which means anything that's not part of your core image will be removed. But the default behavior is that user installed applications and data will be preserved with the restore. All right, so thank you everyone. We've got to get off the stage and we can answer more questions out back.